Okay, so the first thing that you always do in these problems is to draw a free body diagram. So this problem talks about a child pulling a sled through the snow at constant velocity. And this is key because that means that acceleration equals 0. Using a force of 50 newtons at an angle of 42 degrees above the ground. So here are your axes, 42 degrees. It tells you that the mass of the sled is 12 kilograms, and it asks you to find mu, which we know is the coefficient of friction. And here is your formula for friction, which means we must be missing some forces in this free body diagram. The first would be friction. You always have gravity down, and you always have normal force upwards. So, because we have this force at an angle, we know that we have to split our forces into the sum of the forces in the x direction and the sum of the forces in the y direction. You always have to do this when you have forces at angles. And because it's moving at constant velocity, the acceleration in the x direction is 0, and because the sled is not rising up off the ground, the acceleration in the y direction is also 0. Now what we need to do is figure out what are our forces in the x direction. Well, we can see that we have friction in the x direction, and it's going in the negative direction. But we also have this x component of the pull force. So that is going to be whatever the pulling force is in the x direction. Now, we can find that x component using trig. Because this is adjacent to the angle, and we know that cosine of any angle is equal to adjacent over hypotenuse, we know that the cosine of 42 is equal to the x component here over the hypotenuse, 50. So if we cross multiply there, we know that that x component of the force is going to be equal to 50 times the cosine of 42. And now we can bring our f to the other side, and that will give us, I'm going to move down a little bit, 50 cosine of 42 equals friction. Well, we know that friction is equal to mu Fn. But what we don't know is what is Fn in this problem, because Fn is not just equal to mg, because you also have this y component of the pull force pulling up. So it's actually helping the normal force in these problems. So what you have to do to find Fn is to use your sum of the forces in the y direction. So we've got the normal force up, but we also have this y component of the pull force, and then minus gravity, of course. So how are we going to find this component? Well, this is opposite the angle. So we know sine of theta equals opposite over hypotenuse. So the sine of 42 is equal to the y component over 50. And if we cross multiply then, we have 50 sine of 42 for our y component, minus, they gave us the mass, 12, times gravity, 10, equals 0. And if we solve for normal force then, we get 86.5 newtons. And then plug this in over here, divide both sides by 86.5, and you get mu equals 0.43 if you are using gravity as 10.